Hey guys, this is a section 5.4 notes. This deals with solving radical equations. Um, so the first example we start with is solving a radical equation with just one radical. All right, so we're going to kind of solve these like algebraic problems where we want to get the radical by itself rather than just a variable. All right, so our first step in A is to move that -1 over. So we get square root of x plus 5. And then when we add the 1 to both sides, we get 4. And now we want to get rid of that square root, okay, that radical. So to get rid of it, we do the opposite of square root. We square, okay, but we need to do it to both sides. So we square both sides to get rid of this radical. Right, the radical and the square cancel out. So you get x plus 5, and then 4 squared is 16. And then we move the 5 over, and we get x equals 11 as our solution. All right. The next one is a cubic function. So let's get the cubic by itself. So we move the 2 over, and we get 2. And now to get rid of the cube root, we cube both sides. So this cancels out, and we get x. 2 cubed is 8. So x equals 8. Now, what I want you to do is try these two on your own. Right, there's an example of a square root, and then there's an example of a cube root function. So try these two. I'm going to have you pause this, and then I'll show you the solutions in a second. So here are the solutions. So for this, get the square root on one side, square both sides, and then solve for x. And then B, you get the cube root on one side, which it already is, cube both sides, and then solve for x. All right, now we're going to do the same exact thing, except this time we're going to check for extraneous solutions. So in these cases, we may get more than one solution for x, and we need to check to see if that solution works. Okay, so after we solve and get solutions, we're going to plug them back into this original radical equation. So let's first solve, right? So again, we need to square both sides to get rid of this square root. Now, you'll see we're squaring x minus 4. It's not just a number on that side. So these cancel out, and we get 3x minus 2 is equal to, now this is x minus 4 times x minus 4. All right, so we need to multiply this out. So we get 3x minus 2. X times x is x squared. Then we get x times negative 4, so negative 4x. And then negative 4 times x gives you negative 8x. I just combine those, skip the step. And then negative 4 times negative 4 is positive 16. All right, now we're going to have to combine everything and set it equal to 0. So 0 equals x squared minus the 3x over, we get negative 11x. And then add the 2 over, and we get positive 18. Now we need to factor. Okay, so we'll get two solutions. So we have x and x. We're looking for what two things multiply to positive 18 but add to negative 11. Right, so we're going to have two negative numbers, right, because negative times negative gives us a positive 18. Now we look at what two numbers multiplied together give us 18 and add to negative 11. So that should be negative 9 and negative 2. That multiplied in positive 18. And when you add them together, you get negative 11 for negative 11x. Now we set them both equal 0. So x equals 9, and x equals 2. Okay, so we solve for the two solutions. Now we need to check for extraneous solutions. Okay, so if we plug in 9 to the original equation and 2 into the original equation, we should be able to check them off and get equal sides on both sides. If they are not equal on both sides, then they are extraneous. Okay, so we need to check these. So let's check x equal 9. So I'm going to plug this into our original equation. Square root of 3 times 9 minus 2 should equal 9 minus 4. So we get 3 times 9, which is 27 minus 2. Square root of 25 is equal to 5, which we know is true. So x equals 9 is a solution. All right. Now let's try x equals 2. So 3 times 2 minus 2 equals 2 minus 4. So we get 3 times 2 is 6, minus 2 is 4. And then square root of 4 equals negative 2. Well, we know we cannot get a negative solution, right, for our square root function. So no, this is not correct, right? Therefore, this one is the extraneous. Okay, so for our answer, right, x equals 8 and x equals 2 is extraneous solution. So I'm just abbreviating extraneous solutions. So this would be your answer. Okay, so what I want you to do is try 3A and B. I want you to solve them just like we did that last example, right? Solve for, and you'll get the solutions, and then you need to just check if they're extraneous or not. So I'll have you pause this, try these two, and then I'll show you the solutions. All right, so here are the solutions to 3A and B. You just had to factor them out. 3A, right, you get solution x equals 8 and negative 1, right? And when you check them, 8 is correct and negative 1 is extraneous because it does not work. B, you get negative 2 and negative 1 after factoring, right? And they both work, so there's two solutions. Therefore, x equals negative 2 and negative 1. All right, so we've done problems with one radical. Now we're going to look at problems with two radicals. Okay, so these are the last type of problems you'll see. So what we're going to need to do is solve, and we want to first isolate this one, and then next we'll solve for this piece. Okay, so when we isolate square root of x plus 9, right, we know we need to square it, and then we move the negative square root of 2x over, we get square root of 2x plus 3, and we're squaring that. Right, this will get rid of that. We get x plus 9 equals. Now, all right, I'm just going to rewrite this instead of writing the square as square root of 2x plus 3 times square root of 2x plus 3, because that's what happens when you square them. Now you need to multiply square root of 2x times square root of 2x. The square roots cancel out, and you just get 2x. Then we do square root of 2x times 3, and then another square root of 2x times 3. So we get plus 6 square root of 2x. And then 3 times 3 is 9. Okay. Now, right, we need to isolate this square root so we can get rid of that. So move everything else over. So minus the 2x over, we get negative x. right? And then minus the 9 over it, we get 0 because it cancels out. All right, so we get negative x equals 6 square root of 2x. Now we're going to do exactly like we did before. We square both sides to get rid of the radical. So negative x squared gives you x squared. Now this square, remember, it goes to the 6 and it goes to this radical. So the radical cancels out, but we also need to square 6. So we get 36, and then we cancel out the radical, so it's times just what was in the radical, so 2x. So we get x squared equals 72x, and then we set it equal to 0, so x squared minus 72x equals 0. Factor out an x, we get x times x minus 72 equals 0. So one of our solutions is x equals 0 from this x here. And then when we set x minus 72 equal to 0, we get x equals 72. Okay, so now these are our two solutions. Last step is to check for extraneous solutions. So let's check x equals 0 first. So I'm going to plug in 0 for x. So 0 plus 9 minus square root of 2 times 0 should equal 3. All right, so this cancels out, and we get square root of 9 equals 3, which it does. Now what about 72? 72 plus 9 minus 2. Oh, sorry, that's in the square root. Square root of 2 times 72 needs to equal 3. Right, so we get square root of 81 minus square root of 144. So we get 9 minus 12 equals 3, which we know doesn't work because that'd be negative 3 equals 3. Therefore, this is extraneous. So x equals 0 and x equals 72 is extraneous solution. Now what I want you to do is try 5a for me. I'm going to pause this and then, sorry, you're going to pause this and then I'll pull up the solution in a second. So pause this, try 5a, and then look over the solution. Here's the solution. So you move the 3x over and then you square both sides just like in the previous example. All right, that cancels out the radical on the left. Then we get everything over to the left side except for that other radical. Square both sides. And then we get all the square roots gone by this point. Right. Now it's just getting everything equal to 0. So everything on one side equal to 0. Where you get this point. And then what I did was I factored out a 4x because 4x squared and negative 48x both have a 4x in common. So I factored out 4x and x minus 12. So I set 4x equal to 0. So x equals 0 and set x minus 12 equal to 0. So x equals 12. And then you just have to check. I didn't write the workout, but check for extraneous solutions. You should see that 12 works and 0 does not work. Okay, so therefore x equals 12 and x equals 0 is the extraneous solution. If you have any questions, let me know. Ask me on Remind or Google Classroom.